This is the entrance to the Renewable Energy Laboratory, University of Peradeniya, THREE-Lanka project co-funded by the European Union. And we can see here the remote lab on hydropower unit. I will briefly explain main components of this thing, and this is the interface and the power switch, and this is the Pelton turbine that we are going to operate, and this Pelton turbine is connected to a dynamometer connected over there, and data cable is connected, and water line and the power line both are connected. So those are the input to the machine, and there is a water reservoir inside, and this line brings water to the turbine, and there is a orifice meter where we can measure the pressure difference and measure the flow rate, and this is the inlet pressure sensor to the turbine, and this is the turbine inlet valve controller, and there is a flow controller to control the flow. So if you look at the interface here, so basically left hand side we can change the loading by using eddy current load dynamometer, and also we can change the flow and the inlet nozzle. Those are the three controllers available, and this is the main features of the machine. And we can detect RPM, torque, pressure values, discharge head, input power, output power, and also the efficiency for various settings. So we will next we'll try to operate this one through remote mode, and there is a camera over there, so remotely we can operate the camera as well as this machine. Now we will move to our remote computer. It is located somewhere distance at the same laboratory premises within the Applied Thermodynamics Laboratory in the University of Peradeniya, and we are moving here, and now this is the remote computer, and we will operate the machine through this computer at a distance. So operate please. Now start button. Now you can see the machine is in operation, and there are three controllers available. We can from distance we can hear the noise, and we can change the loading as well as flow control as well as the nozzle control to the inlet. So you can see here the RPM and the pressure values, and also discharge and the efficiency and so on. And increase the load please. Now the dynamometer load is increased, so we will see the changes. Now gradually the efficiency increases, by this way we can optimize the conditions to get the maximum efficiency using basic trial and error, and all the and also this the machine is having a set point for maximum operation. So we will again move into the machine which is located at a distance from inside the Renewable Energy Laboratory. Here is the machine in operation. the data from this one, data sheet. We can generate the data sheet. So we can name it organization, operator names and remarks, and observation table. Get the RPM, torque, pressure values, and also the calculation and the calculation discharge rate and efficiency. You can directly obtain this values observation table. Can generate report itself. We can generate the graphs as well. For a smaller time period, there is a small thing only, and so basically we can get this rate.
Welcome to Sri-Lanka Remote Lab prepared by the University of Jaffna. The title of this practical is Testing Solar DC Water Pump Performance. The objective of this practical is to evaluate the performance of a solar DC water pump by measuring flow rate and efficiency under various conditions, including generated power, startup voltage, pump head, temperature, solar intensity, and battery backup. This is the list of apparatus to set up this practical. 12V solar DC water pump. Solar panel. Adjustable solar panel mount. Water reservoir or source. Measuring containers. Multimeter. Pyranometer, to measure solar insolation. Thermometer. Stopwatch or timer. Data recording sheet or logbook. Battery backup system. Remote lab setup. This is the overall remote lab setup arranged at Kilinochchi Center for the Solar Water Pump Practical. This practical setup can be controlled remotely using a PLC and HMI. This HMI interface controls the practical setup and records the readings. This is the motor control switch, which can be used to switch on and off the motor. This is the solar panel control switch. These are solenoid valve control switches. By using these switches, we can open or close the solenoid valves to adjust the outlet head of the pump. 2 cameras are fixed to focus the practical setup. One camera is arranged to focus on the inside equipment arrangements, such as the PLC, motor, HMI, its connections, and readings. Another camera focuses on outside equipment, such as solar panel and water outlets. Both can be controlled through the HMI interface. Now, let's move to the first task. Flow rate and efficiency versus generated power by the solar panel. Let's first set up the experimental setup. First, place the solar panel in direct sunlight and adjust the angle of the solar panel to maximize power output. The motor is connected with a battery and controlled by a relay. PLC and HMI are connected to control and monitor the practical setup. DC supply is used to power up the HMI. Arduino with voltage and current sensor is used to measure the power. Readings can be collected from the Arduino serial monitor. This is the overall wire connection setup. The solar panel is connected to an MPPT and charger controller, which is connected to a battery and motor. A solenoid valve or potentiometer is connected with the motor to adjust the outlet head of the pump. Logic has been created so that if and only if one valve is on, then only the motor can be turned on. The current sensor is connected in series to the positive terminal, and the voltage sensor is connected parallel to the supply. Now, let's start the experiment. Switch on the first valve to open this outlet and switch on the motor. After operating the motor, water will be pumped from one outlet. This pumped water is then collected in a container. Then, measure the time taken to fill that known volume container. The ammeter and voltmeter readings can be downloaded from an Arduino serial monitor. With the measured readings, calculate the flow rate and efficiency using these two formulas given in the lab sheet. Repeat the procedure and record the flow rate, power, and efficiency at different power outputs. Discuss how the power output from the solar panel affects the flow rate and efficiency. Task 2, Efficiency and Flow Rate versus Pump Head Test. For Task 2, first, set the pump to lift water to different heights. Here, we have designed outlets that are 1 meter and 1.5 meters in height. The two solenoid valves are used to adjust the height and can be controlled by these switches. Step 2, repeat the procedure we did in Task 1 and record the flow rate at each height. First, switch on the first control switch to open this valve and start the motor. Then, collect the pumped water from the first outlet, which is fixed at 1 meter height, and calculate the flow rate. Then switch off the first control switch and switch on the second control switch to open this valve and start the motor. Collect the pumped water from the second outlet, which is fixed at 1.5 meters in height, and calculate the flow rate. Now calculate the efficiency using the above-mentioned formula and fill the given table. Repeat the steps at different heads and evaluate how different heads affect flow rate and efficiency. Task 3, Battery Backup Test. To test the battery backup, connect the pump to the battery pack charged by the solar panel. Repeat the procedure we did in Task 1 and Task 2 when powered by the battery. Measure and record the flow rate and efficiency at different solar panel power outputs and heads. Compare the performance under direct solar power and battery backup. Thank you.
This is the remote photovoltaic equipment, and this equipment consists of a solar panel with some lights at the back, which we have turned off for the video purposes, and we have some power supply which we use to control the solar panel, and the equipment has a local computer station which all the equipment are connected and operated, so either we can operate it locally or someone can connect remotely to this equipment and control the entire system from remote location. This is the entire setup we have as a solar PV lab. Okay, this is the solar photovoltaic remote lab equipment, and this is the remote view when student connected. This is what student will see. So in this screen we have a camera which is showing the solar panel situation, how it is now situated at the remote location, and we have equipment called DC load connected to that solar PV panel, and this equipment we can change the voltage of the solar panel basically to set different constant voltages and get different power levels from this equipment. And then to control the angle of solar panel, we have a solar panel controller here. By changing this slider, student can remotely change the location. As you can see, the panel changes, so student can change this to the desired value. You can either slide this or you can just set a value by typing and position the solar panel as required, and we can turn it in both ways if necessary. And with that, the equipment will show you how the voltage and current changes. This is, we are turning on the equipment for remote control, and with this, now the equipment was connected, the equipment now this is on, and you can set different voltage levels for the panels, and by moving this slider, or by just entering some value you like and pressing enter. You can enter value you like, and according to that the solar panel will change its output. So this is the setup you will see as a remote student, and he can get parameters, he can see parameters from here, he can visually monitor what happens to the panel here and get required details. This is the remote operation part.
In this video, I would like to give a brief description of the remote lab that was developed by SLIT for monitoring battery system parameters. If you consider the system that we have developed, it demonstrates the charging and discharging of 10 lithium-ion batteries. So each of these batteries are 3.7 volts and they can handle up to 2 amperes of current, and these are connected in series. So once they are connected, if they are charged, each has 3.7 volts, the system would provide 37 volts. So these batteries can handle 2 amperes of current. And if I go through the different components of the system, now to handle the charging and discharging of the batteries, we are using a battery management system, and this battery management system could be connected to different cells. Each of these cells, then here in this setup, there is a DC load that we have connected this battery system, and to carry out the charging and discharging, we need to simulate a solar PV simulator. So for that, we are using two power supplies to provide the right voltage and current. So here you can see the setup which is connected, and now it in the lab there is a PTZ camera where you can tilt and pan and zoom and see different components. So here you can see that by pressing the arrow keys, you can turn the camera to left and right to see exactly what's around. Now this is carried out remotely. So the controlling of the camera could be carried out from a remote location. And next, I would like to show you the next interface where the remote user sees. Now here in this remote interface, you can see now if they go through this menu, they can monitor different parameters of the system, such as constant current, constant voltage, constant resistance, constant power, and so on. Now these are some of the parameters that the remote users can monitor, and they can see how the system current and voltage changes, and also it plots the power. Now they can monitor the voltage, current, and power in real time of the total system. Here in this case, now if we consider the voltage, I told you that there are 10 cells connected, so it will have a total voltage of 37 volts. You can see that it gives a voltage of 37 here in this system. The voltage of between 30 and 40. And here you can see that if you follow the cursor, in fact you can see the charging and discharging of the 10 cells. You can see here in this system. So the user can change different parameters and they can see each and every parameter that they are interested, the voltage, current, and they can calculate the power also. And it shows the charging and discharging in real time, and it shows how the battery management system controls this charging and discharging of these individual cells. So this is the brief description of our system. Thank you very much everyone for watching.